All right. So let's pick up using these log rules to expand and condense some logarithms. You'll notice that this set of notes has already been started. I'll sort of post as a little bonus from a few days ago, the last time I recorded, when my cat jumped up and got into the frame, and in trying to get him out of the frame, knocked my water bottle all over my computer and killed it. So magically I was able to reboot it and get the video of the incident. So I'll post that as a bonus. If you want, you can sort of see me talk through these first examples in real time. I'll talk through them again now, and then we'll keep going. So as a recap, we have our three log rules. So the product rule, the log base b of m times n, is going to be equal to the log base b of m plus the log base b of n, right? So we're splitting from multiplication on the inside into two separate logs that are added together. We have a similar setup where we split division into subtraction, and you can sort of expand the multiplication idea, right? And if you have something raised to a power, this would in theory be like log base b of m plus log base b of m plus log base b of m, however many times you have in the exponent. You can then simplify that and just sort of have whatever this power is times the log base b of m. So the sort of power rule is the power will come down in front. It's really an expansion of the exponent rule, but in theory it works, the product rule, but in theory it works for any kind of power, not just sort of positive whole number powers. So we're going to use these rules, sort of combinations of them, to sort of expand logs out, and then we'll do a couple examples where we condense them back together as well. So first things first, if we've got a log base 5 of 25x cubed, like this, what we want to do is expand it out into multiple individual logs with sort of simpler terms inside. The first step is to say, well, what's inside of my logarithm? It's 25 times x cubed, so the sort of main operation here is multiplication. There's obviously also a cubing, which in theory will come down in front, but we have to get it separated before we're going to bring it down. So I need to have only the x cubed, not sort of also multiplied by the 25. So the first thing is a product rule, where you're going to break this up into two individual logs, so the log base 5 of 25 plus the log base 5 of x cubed, right, using our product rule. Individually then, so the log base 5 of 25, we can actually evaluate that. I mean, these are numbers and they're sort of nice enough numbers, they're related, right? So because 5 raised to the 2 is 25, that log by itself actually just becomes 2, right? Gives us the power that it would take to get from 5 to 25. So that whole thing just becomes a 2. Plus the log base 5 of x cubed. Now that this portion is separated, right, is on its own, we can sort of use this and bring the exponent down in front, so it'll become 3 times the log base 5 of x. So the log base 5 of 25 becomes this 2 plus 3 times the log base 5 of x. If we run a second example, similar kind of thing, we'll sort of take a longer log and try to expand it. Let's do log base 2 of, let's do x to the 4 y squared over the square root of w. So this is like a little bit bigger, similar kind of ideas. What we have really as our sort of main first step is really going to be the division. I mean, we have sort of just on the top something similar to what we just did, but there's also a division and then this sort of root on the bottom. So before we sort of deal with the top and the bottom individually, we need to kind of get them separated. That for us is going to be our quotient rule. Let's start with the green again. So we'll do quotient first. So that's going to be just taking log base 2 of the numerator, x to the 4 y squared, and we're going to subtract the denominator, log base 2 of root of w. From there, what we can do is look at each of these logs individually and then sort of continue to use these rules to sort of break this apart. This will break down quite a bit. We have maybe a little bit of each of these rules happening here. Let's do, I'm going to take this maybe straight down first and then over. The next thing I want to do is take this log base 2. So this is x to the 4 times y squared. So it's two different exponents. Before we can bring those exponents down in front with the power rule, we're going to have to break this up into two individual logs. So we'll use our product first. So this is going to become for us, right, so log base 2 of x to the 4 plus log base 2 of y squared. So the product, right, we had sort of two terms multiplied together up in the numerator. So we're going to flip that multiplication and expand those two logs out. The second thing we'll do with this sort of subtract, right, minus log base 2 of the root of w. Root of w written as a root we can't really do anything with, but a square root is really just w raised to the 1/2 power. So what I'll just do is a quick rewrite. So we're just using the fact that the root of w is the same thing as w to the 1/2, right? A square root is a 1/2 power. So if I take any kind of roots, I can sort of use these log rules to help simplify them and clean things up. The catch is, right, to do that, I need to sort of rewrite those roots as exponents. Once I've got that written out, the last step here is just going to be 3 individual power rules, right? So everything is sort of just a variable raised to a different power. So I'm just going to do power rule 3 times. So this would be 4 times the log base 2 of x plus 2 times log base 2 of y minus, right, because that was on the bottom, log base 2 of this w. That's going to be our final form. This is sort of all variable based. There were no pure numbers here, right, for us to be able to sort of actually evaluate any of these logs. We're sort of just stuck with the variable versions, but that's totally fine. If we get numbers for these variables, well, then we could sub them in and evaluate this. But as far as just an exercise in rewriting it, we don't have to do that. Let's flip this around. So instead of expanding, let's run this in reverse, and let's condense the logs. So what that means for us is we're going to essentially run something similar to the problems that we just did, but we're going to run them more or less in reverse. So taking something that's expanded out into multiple logs and then sort of working our way back to a single log, just using these same rules. We'll start with a little bit of a shorter one and then we'll do a longer one. So how about, let's do some natural log stuff. Let's do natural log of 6 plus 4 times natural log of z minus 2 times natural log of, t. A little random with these variables, but that's okay. Can't use x every time, right? Get a little creative. So what do we need to do to condense these logs together? A couple things sort of stand out as a first step. So draw your eyes to the values out in front. So this sort of 4 in front of the natural log, 2 in front of the natural log. I can't use my power rule or my quotient rule to condense stuff together unless I get those coefficients out in front up back into the exponent position. I need to use my power rule first, really, before I can do any sort of product or quotient. So the first thing we're going to do is just use power rule. Our first log is just natural log of 6, so there wasn't an exponent there, so there's nothing to change there. That one's just sort of hanging out for the moment. And so 4 times the natural log of z, that's really going to be the natural log of z raised to the 4. So the idea, right, is I can take this 4 and raise it up into the exponent. I gotta watch my signs a little bit, right? So minus the last one, the natural log of t. So 2 times that natural log is going to leave me with the natural log of t squared. So using the power rule, right, what it does is it gives me right, these sort of 3 individuals, and it gives me them with only the natural log in front. I'm able to take these coefficients out of the picture. That's a good first step. From here, let me sort of do these a little bit separately, maybe. So what I would do first, right, the addition here is going to be our product. So that's going to be the natural log of the product of the two things, 6 times z to the 4. And then we're sort of minus the natural log of t squared. Once I have that taken care of, right? So the last thing is going to be to say, okay, so 6z to the 4 is kind of my numerator value, right? Minus this natural log, so the subtraction gives me a quotient. So my final version, if I do some quotient stuff, I'm going to have the natural log, so fraction style, so the first term, 6z to the 4, is my numerator, divided by the second term, which is this, t squared. And that's going to be our final solution, right? So just sort of taking everything and compressing it, condensing it down into one log. I'll do one more example just to show you what would happen if we had multiple terms in our denominator. So that would sort of mean that we had, let's do sort of a log base 10, right? So just regular log. So I don't know, log of x. We'll go back to x. Let's do minus 3 times log y minus log z. Okay, just a little close to this other one. So x, y, and z, not too many powers here. I really want to focus more just on this sort of like double subtraction. That's kind of the key to this one. There's a couple different ways we can think of this. I guess actually before we do that, we should do this power. So this is going to be log x, so minus log of y cubed minus log of z. So that's really a step one, right? Just using our power to make that transition. Again, we can't do any sort of quotient stuff, we can't do any sort of product stuff until we've taken care of that as a first step. What I'm going to do here is if we sort of note this, so what I can do is actually call this, right? So both of these are subtracted. In theory, what that means is they're both going to end up in the denominator. I'm going to try to do this in a way that's as clean as possible. There's a couple different ways you can do this. You sometimes end up with like fraction stacks, right? If you kind of did like x over y cubed, and then you did that whole thing over a z, right? You get sort of this pancake stack of a fraction on the inside. It's not the nicest thing in the world to work with. So what I'll note, right, is that this is really, if this is minus and this is minus, I can do one subtraction out in front, and this would really be the log of y cubed plus, in parentheses, right, this second log, the log of z. And so if I make that tiny change, that just like small notation change, this allows me to then take in the parentheses and do a product. So then this is going to become log x minus, so in my parentheses, the log of, so because in the parentheses it's addition, that means again in my parentheses it's going to turn into multiplication. So this helps a little bit to sort of figure out where all these different terms are going to end up. So I have really now two logs, one sort of positive log that would be a numerator, one subtraction, right, one negative log that's going to end up in the denominator. So this becomes, as a final step, the log of the fraction x over y cubed times z. So again, there's a couple different ways that you can get to that last step, to sort of run through that last example. That's probably the cleanest way to do it with sort of the least amount of fuss. But you could do some sort of fraction stack and make that work also. It just might be a little bit less natural depending on what you're more comfortable with. That's the basics of it. End of 4.3.